Here's a number that should bother you. Waiting just 10 years to start investing can cut your final balance by more than half, even if you invest the exact same amount every single month. That's the power and the cost of compound interest. And by the end of this video, you'll understand exactly why. Compound interest is simple in concept. You earn returns not just on the money you put in, but on the returns you already earned. Every year, your gains start generating their own gains. In year 1, that effect is barely noticeable. By year 20 or 30, it becomes the single biggest factor in how much wealth you actually build. Bigger than how much you started with, and often bigger than how much you contribute along the way. Let's make this concrete with an illustrative example. Say you invest $200 a month, and for the sake of this example, assume an average annual return of 8%. That's a commonly used illustrative assumption in long-term financial planning, roughly in the range of historical stock market averages. Though actual returns vary a lot year to year, some years are sharply negative, and nothing is guaranteed. If you start at age 25 and keep going for 40 years, that $200 a month grows to somewhere around $698,000 by age 65. Now here's the part that should bother you. If you wait until age 35 to start, investing that exact same $200 a month for 30 years instead of 40, you end up with roughly $298,000. 10 extra years of contributions is worth over $400,000 in this example. You didn't invest twice as much money to get that difference. You just gave it more time to compound. In fact, the total amount you'd contribute out of pocket only differs by $24,000 between the two scenarios. $24,000 in contributions, turning into a $400,000 difference in outcome. That gap is entirely the cost of 10 years of lost compounding. Here's a mental shortcut that makes this easier to reason about. The rule of 72. Divide 72 by your expected annual return, and you get roughly how many years it takes your money to double. At 8%, that's 72 divided by 8, or 9 years. So in our example, the 25-year-old's money doubles roughly 4 times over 40 years. The 35-year-old's money only gets a bit over 3 doublings in 30 years. Missing that extra doubling near the end, when the balance is largest, is where most of that $400,000 gap comes from. That's really the core insight people miss about compounding. It's not linear, it's exponential. And exponential growth is backloaded. The dollar you invest in your first year does the least work in year 1, and the most work by year 30, because it has the most time to double and double again, which means the years you're most tempted to skip, the early ones when your account balance looks small and unimpressive, are actually the years doing the most long-term heavy lifting. This is why the common advice to start investing early isn't just generic encouragement, it's math. The first years you invest aren't just building a balance, they're buying time for compounding to do the heavy lifting later. A dollar invested at 25 has 40 years to compound. That same dollar invested at 35 only has 30 years. It's not primarily about how much you start with. It's about how long your money gets to grow. None of this means timing the market or waiting for ideal conditions. Markets go up and down in the short term, and this example uses a simplified, constant average return to illustrate the concept. Real returns are messier. But the underlying math of compounding doesn't change. Time in the market is the input you have the most control over, and it's the one that costs you the most when you delay it. So if you've been waiting for a bigger paycheck or the perfect moment to start, the math says the cost of waiting is usually bigger than the benefit of waiting. Start with whatever amount you can today, even if it's a fraction of $200 a month, and let time do what it does best. If this made compound interest click for you, subscribe. There's a lot more where this came from.